This is a video presentation of Chapter 8, Section 5 in the 8th grade textbook entitled Volumes of Prisms and Cylinders. And here, that's pretty much all they're going to have us do. There's not a whole lot of spice of life in this section. Alright, they're just going to really have us working with those volumes. So, one thing they don't do here, shame on the book, but they don't really define volume. What is volume? Volume is the amount of space something occupies. All right. So in this section, because we're talking about three-dimensional shapes that we can put measure to, really. All right. We're asking how much space does that three-dimensional shape occupy in Earth, on the planet, in the world, whatever you want me to say. All right. Now, volume does not just apply to three-dimensional shapes, even though just looking at the book questions here, you might think it does. Volume can apply to any shape. All right. The best example I can give, and the one that most people will be able to easily understand, would be a rock. Okay. Most rocks are not perfect cylinders or cubes or anything like that. All right. But a rock takes up some amount of space on Earth. All right. Now you say, well, how do we find out how much? Well, usually what we do is we fill an object with liquid. And because we're talking a little bit mathematical still here, let's stick with a graduated cylinder. All right, graduated cylinder in science has measurements on it, so we know how much liquid is in there. Okay, so we put some water in the graduated cylinder, and then we drop the rock in. And you all know what's going to happen. When I drop the rock in, the amount of liquid is going to appear to go up. It's the same amount of liquid, but it's going to go up the graduated cylinder because you've displaced some of the water with the rock. Well, you're going to take your measurement on the graduated cylinder before and the measurement on the graduated cylinder after, and how much ever water is displaced, the change there is the volume of the rock. Now, obviously, you could kind of measure it and estimate it based on what it looks like. If it's kind of squared off, maybe at the sides, it's been beaten up a little bit, it might look a little bit like a prism. All right, might look a little bit more like a sphere, which is something else you could use. Maybe it looks a little bit like a cylinder. All right, but those are only approximations. But using the graduated cylinder technique is really a pretty exact science there. And we can apply that to any shape that's not a standard three-dimensional figure. That same concept will work. Don't think of weight here. It's not weight. All right, that's what it's not. All right, it's just how much space that shape occupies. All right, so we're limiting ourselves to prisms and cylinders here today. So let's go ahead and start off with example number 1. Now, obviously here, if they're having us find volume, there must be some formulas involved. And those formulas are embedded in the examples here today. So we don't have to worry about what's the formula, why didn't they teach that to me? It's in the questions. All right, so part A says we've got a rectangular prism with a base that measures 2 by 5 and a height that measures 3, and those are all given in centimeters, and we're finding the volume. Well, right there, you just saw me highlight the formula. Volume is equal to the area of the base times the height. Now remember, in a prism, the base can be any shape really from 3 sides on up. All right? So they can't give you a static formula, and by a static formula I mean something that always works. All right, because here that base is going to change. All right, you're going to see in a minute here when we go down to the cylinder, they're actually going to change the formula up a little bit because it's static. The base is always a circle, no choices in life. All right, but here right now, there's only one choice. All right, or there's many choices here, so you've got to use